Hey everyone, it's Jim
And Charles.
from Vowels and More, an online vintage tube store. And today in Tube Lab number 224, I think.
Sometimes it's hard to keep track of them.
We're going to talk a little bit about how to minimize your system noise floor. And but first, before we get into that, caution everyone, electronics and tube amplifiers can have very high voltages present, which can be lethal. Exercise extreme caution when working around them. Always consult a professional technician when in doubt. Okay, first the bad news. Tube gear will almost always have a higher noise floor than solid state. There's a number of reasons for this, but it mainly comes down to the fact that vacuum tubes and related circuitry make more noise than transistors. And then when you realize that modern solid state gear is made with integrated chips, ICs, and surface mount devices, or SMDs, which are invariably very low noise, it's not hard to understand why solid state wins when it comes to the amount of self-noise generated. Now, when it comes to sound, well, that's a completely different story. Now, the good news. If you set up your system with care, you can actually reduce your overall noise floor. Okay, let's take a quick look at some layouts. We haven't had these cards out for a while. So noise is introduced at every single stage of audio. So way back at the recording stage, the microphone is going to have a certain level of self-noise. The circuitry in the microphone, the cable, the preamps.
Even something as simple as just moisture in the air from the singer impacting on it.
Yeah, and that's why, of course, you use a pop filter to try to keep that moisture off of the diaphragm. The mixing console absolutely is going to have a lot of self-noise. If you're recording in all analog, you might be recording to tape, which is how everything was recorded years and years ago. Pardon my hair. But today you're basically recording to digital onto a computer, unless you know what you're doing. No, I didn't say that, did I? I did. But what is with all, we're actually looking after our my mom's Charles's grandmother's little Yorkie Terrier who had surgery on Monday.
And all of a sudden there's little hairs everywhere.
Yeah. Well, they're going to start showing up on our records next.
Probably.
So what does this noise look like? Well, let's just drop a card in here for just a second. And here we've got our fundamental or our audio signal. And I've just drawn a 1 kilohertz sine wave, which is how typically people represent an analog signal. The reality is a lot different than that, and I'll show you in a minute. So that's going to be as loud as we can safely record without saturating. So that would be on tape. Digital has the same issue. You have to be well within the limits of the maximum recording level. What does the noise floor look like? Well, it's hopefully a lot smaller. Now, I've drawn this sort of as, maybe, let's say 10 or 15% of the signal, but in reality, it's going to be well below 1%. And it would be even hard to make a pictorial representation. But this is just sort of a fanciful representation of what it looks like. This would be more the reality. And I've actually drawn the audio signal and the noise floor in two different colors. But the reality, of course, is that they would all be integrated.
Essentially merged.
And what I've done here is not true to what you would see on an oscilloscope if you looked at the signal. But it's to give you a sort of a sense of what an audio signal would look like. But that noise floor would actually be riding around with this fundamental signal. And it's hard to describe, and it's hard to even put it on the scope for you, but it would just muddy it up very slightly. What really matters, though, is what you can hear, and that's what we're talking about right now. So we can't do anything about what happened way back at the recording stage. So let's just forget about that. I mean, we can in a way. Choosing high quality recordings really makes a huge difference to your listening experience. And if you're an old time audiophile like I am, I'm now in my, oh God, am I in my 50th year? Anyways. No, it can't be. No, it's not. It's not quite my 50th year. I'm still late in my 40th year as an audiophile. And Charles is relatively a newbie when it comes
to the audiophile state.
to the audiophile club. Yeah. I don't know if it's a scene. It's not like a dating scene. In fact, us audiophiles tend to be sort of like hermits in our little audio caves.
Can be.
Can be. So, but I just had a gentleman over, last weekend or the weekend before to listen to Open Baffle speakers. A really nice fellow, and we had a good chat about audio. So maybe I'm not such a hermit anyways. And our music room's above ground, so it's not really a cave.
Yeah.
Yeah. So
A little nicer.
anyways.
Back to the topic at hand.
So, I mean, Charles brings a fresh perspective, and he's probably more on a parallel or analog. I just could.
There's a new word for you.
Yeah, that was a good word too. I think with a lot of our customers, you know, who have discovered how great audio can sound and just continue to improve it. So, let's get in system. So, what's going on at the very beginning? We're going to have some source. So it's going to be a DAC and fed via a streaming device. It could be an all-in-one unit. It could be a computer, whatever on your digital side. And as you know, I'm not a huge fan of digital. Final playback. There's self-noise on the actual surface of the record, believe it or not. Just the noise of the stylus scraping through the pressed plastic disc is a noise. Now, that becomes part of the noise floor. In fact, let's bring the noise floor up here, just so that we can keep an eye on it. And then we've got all of the noise floor that's in the recording. Now, if the recording engineers, remastering engineer, all the way through the signal chain are paying attention, and they almost always are, they're going to try to keep the signal really loud and the noise really low. So at this point, we're probably not going to hear a heck of a lot of the noise floor. Though Charles's hearing is still so good that he can actually hear on older recordings, he can hear some tape hiss, which is normal. But you have to have some pretty good ears to do that.
Yeah, it's fairly low, but you can hear it.
And you're going to have a very high resolving system as well.
Yeah.
So we move forward. We're going to come through a preamp, and for this I've actually made a new drawing of our modern line 6N1P, and we're actually going to talk about that at the end a little bit. And it's a high gain preamp with low noise. So, and we actually tried to set up an in the music room demo in which we ganged up a bunch of preamplifiers, and I'm missing a phono preamp in this card display, but anyways, everybody...
Let's pretend it's in between.
Let's pretend there's a phono preamp in this stage over here. We don't need one over here, of course. And the current Rocket version that we're releasing, version 1.1, is so low noise that even with two of these ganged together, we really couldn't create a demonstration that made any sense.
Yeah, you wouldn't have been able to hear it on camera unless we had the microphone pressed right to the speaker.
So that wasn't going to work. And then, of course, we've got a mono block, and then we've got speakers. Now, how does all of this relate to your noise floor? Well, we've already said we really can't do anything about the noise floor at this stage, other than perhaps choosing high-quality recordings. The noise that we do inherit from our playback systems is going to always be present. Okay, so let me repeat that. Whatever the noise is that arrives at our playback systems, that is going to never go away.
But not without losing music along with it.
That's right. We could filter it out. So let's say we had the original recording had a flaw at the mastering stage, and they put some low frequency 60 hertz noise in there that they didn't hear it in their test system, simply because they just didn't go down that low, and it managed to make it out to you. So you could filter out that 60 hertz, and that would mean you would be filtering everything from about, to catch 60 hertz, you're probably going to be filtering at least 70 or 80 hertz all the way down to zero.
Mm-hmm. So everything there gets rolled off.
That means you've just lost your whole bottom end. So you really don't want to be doing that kind of filtering. In fact, when we design gear, we design it with wide band amplification. Mm-hmm. And what that means is we amplify everything in the audio band and even outside of it. And the reason we do that is because it sounds better.
Yeah, we want all the music we can get.
Yeah, particularly those bass notes.
Yeah, so if we've got noise that's coming into the high gain preamp, that noise is going to get amplified.
Okay, so if we've got our fundamental or our signal is a lot louder than that noise floor, then we'll be able to safely amplify that. We're going to bring up the audio signal and its noise floor. But if the self noise of the Rocket or whatever preamp you're using, or phono preamp, is relatively low, we're going to be fairly safe. Over here at our power amp, the same thing is going to happen. We're going to amplify everything from the previous stages. So we pick up in the recording studio some noise. We pick up some noise at this stage, at the playback stage. Our phono preamp is probably going to add a fair amount of noise simply because they're extremely high gain. Because the signal off of here is very low. Signal off of a record is typically about 5 millivolts, so 5/1000ths of a volt. It can be even lower than that. Off of a reel-to-reel tape machine is typically 2 millivolts, so half of this.
Yeah.
Off of your DAC, it's going to be a nominal 1 to 2 volts RMS, or 1,000 to 2,000 volts RMS. So you can see how the digital side is almost certainly always going to be a lot lower noise than a vinyl or tape playback system. It's in the cards. It's baked into the technology. Now, so we've amplified everything that we've accumulated. What about the speakers? They don't matter at all, do they?
Oh,
they actually do, because speakers have different efficiencies. So 86 dB for a nice bookshelf ELAC. An expensive pair of B&Ws are about 90 dB efficient. Now, this is not a linear scale. Decibels move up exponentially. So 86 to 90 dB is a huge improvement in efficiency. Our own open baffles are about 93 dB. So they're roughly as much more efficient than the B&Ws as the B&Ws are to the ELACs, roughly. And the more efficient your speakers, the more you're going to hear into the noise floor. And it's
essentially the lower the signal you need to drive it into the audible range.
Yeah. Now, there's some give and take, of course, but for noise floor testing, we really love having fairly efficient. 93 dB is the very beginning of what I would call a high-efficiency speaker system. Really high efficiency speakers go all the way up to 102, 103 dB.
I think even some around 108 at the absolute max there.
Yeah. And at that kind of efficiency, you have a speaker that you can put a couple of watts into and actually amplify a movie house, which is how those...
It's pretty incredible, yeah.
That's what those high-efficiency speakers were used for back in the day. So, and now, how are we going to deal with reducing our noise floor? Well, we're probably always going to play our favorite tracks back on our favorite playback system. But what you don't want to do is to have a lot of noise floor early in the signal chain. Now, obviously, if we went all the way back to the beginning in the studio, let's bring the studio back in. If we had a really noisy microphone and the noise was not filterable, so it's all in the mid-band, right in the vocal range, that would be a disaster for everybody. And probably eventually that recording would have to be redone, because there's some high technology out there that's being reused these days to bring out tracks and clean them up. But you've essentially got a computer program basically taking apart the audio and putting it all back together again.
And a lot of that is for degraded media that's actually been damaged over time or use.
Yeah, well, the so-called last Beatles track, which I adore, was actually rescued using technology developed for the Beatles documentary. And I've forgotten the name of the director. The director is the director from The Lord of the Rings, the good original series.
Peter Jackson.
Peter Jackson, yeah. So he brought I don't think he developed the technology, but he had his team develop that technology, or find a company to develop that technology.
So basically what we're saying here is that you want to try and keep your fundamental signal as far away from your noise floor as possible, as early as possible.
So how would you do that? So what if you have a DAC that has got a variable output, or it's got a high-low switch on them, which is really very common. So you don't want to distort your output stage at any stage.
So if you have something that will distort at full volume, don't set it to that.
You're going to have to bring it back a bit.
Yeah.
But if you can set your DAC at your maximum volume, or your phono cartridge. Now, because we're getting close to releasing the new modern line kit phono preamp, we're having discussions with people. And a lot of people are running moving coil cartridges, which are extremely low output cartridges. And as a result, they need a lot of gain, a lot more gain than a moving iron or moving magnet cartridge does. So right away, they start off with
a higher noise floor.
Yeah, a lot higher noise floor. And it becomes, it's almost a game of whack-a-mole to see, how short the cables, how low noise the cables, where to position the preamps. So if you start off with a decent output at the cartridge level, or a nice high output at the DAC, you're starting to win this war with your noise floor right off the bat.
You've already spaced them out a fair distance.
Yeah.
Yeah.
Moving forward, at every stage of the game, you want to have more gain on your fundamental or your signal than you do later in the stages.
Yeah, so more gain early, less gain later. Because as it's going into later stages that have control over the volume, it will be tapering off or sending some of the signal and some of the noise floor to ground. And that should help get rid of most of that noise floor in later stages.
Yeah. So that's the general rule. Some things, though, I wouldn't recommend. For example, I'm a firm believer that high-efficiency speaker systems sound better. I think it's just a fundamental fact, and they have more advantages than that. So you need less power, more efficient speakers, less power. And what basically happened with speakers is in the 70s, all of a sudden we could have 1,000 watt amplification, and speaker designers got lazy.
Yeah. No longer have to make it efficient.
Yeah. And that was easier on them, but frankly, I don't think they sound very good. The transient response of an inefficient speaker system is nowhere near as good sounding as a more efficient speaker system, in my opinion. There's a lot of other reasons why I prefer more efficiency. So we're going to probably choose a speaker system that is going to right away make any noise floor that's way back here or amplified through here more apparent. So it's even more important that we pay attention to detail all the way along. So keeping the signal up relative to the noise is extremely important, but there's dozens of other things to keep in mind. And one of the main things is our listening rooms, our lives, in fact, are filled with noise now, electronic noise, EMI, and it's literally everywhere. And a lot of it's in extremely high frequencies.
Yep. Things like Wi-Fi, Bluetooth, operating in the gigahertz ranges.
So a lot of that is simply outside of the audio band, and we're not going to hear it, hopefully. In fact, the average middle-aged human being hears roughly to about 11,000 cycles, or 11 kilohertz.
But even though it's out of that range, it still can have an audible impact if it's close enough to something.
Yep. So it'll start to actually sound like a very high frequency buzz.
Mm-hmm. Or if you've ever heard, if you had a very early cell phone next to a poorly shielded computer speaker back in the 90s or something like that.
Chirp.
Yeah, you'd hear that sort of pulsing chirping sound. It can also sound like that.
Yeah. And that's just the beginning of noise. Our lights are now electronic devices.
There's smart home things all over the place that go through the power line or over Wi-Fi.
All of our appliances have devices in them that are emitting stuff. Mm-hmm. Heck, even our credit cards have
little NFC chips in them.
So there is noise everywhere. So in your music room, have a really good look around and decide what actually has to be in there and get all that other electronic junk the heck out of there, or move it as far away from your system as possible. And you might have to experiment. So you might find that if you have your DAC turned up to its maximum output, you're hearing some distortion. So turn it down a little bit. You might find that a certain tube that you're using is really quite noisy. Mm-hmm. And in which case, it may actually be a tube that goes in the garbage. We throw out thousands of tubes every year, and a lot of the tubes we throw out are just simply because they're noisy.
Yep.
So it could be just changing out the tube to a low noise tube.
Will make a big difference right there. Or, if it's low testing, if you've got a low testing tube, the noise floor in comparison to the signal that it's amplifying is going to be much higher. So to get the same amount of volume, you're going to have to turn it up, and up comes the noise floor along with it.
Right. Yeah. I mean, in older equipment, volume pots can be noisy, and they literally either need to be cleaned or replaced. I remember years ago, one of my first tube amps had an Alps pot, but it had been in service for so long that it had become noisy, and the difference between a new Alps pot and the old Alps pot was like night and day. And I think it took me 20 minutes start to finish to drop a new pot in. So yeah, I mean, it can be literally anywhere and everywhere. Poorly shielded cables.
Poorly shielded cables, bad ground connections, corroded connections on RCA jacks.
Yeah, we could
probably talk for a few hours here.
I think we could keep going till next Friday. Maybe we should do a marathon one day and we just keep going until we shut up.
Yeah, maybe.
Yeah, or one of us dies.
Yeah, or we lose all our subscribers.
Whichever comes first.
Yeah.
Anyways, we've got a few fun things to show you that came in, and let's just change over. Well, Charles just said to me, let's see if we can get the focus on this thing a little bit better. There, I think we got it. Charles just said to me that that's not a new arrival. I said, well,
technically we built it.
Yeah. So the over at Melotone Amps, the first product that the new company and the new website has available is the Rocket, and it's called the Rocket. It was named the Rocket because this great sounding Soviet era tube, the 6N1P, this is the EV version, the mil-spec or heavy duty version, just sounds so amazing. In fact, when I first discovered that tube, I said, someday I'm going to build a great sounding preamp around it. And well, that day arrived.
Yeah. And they're called Voskhod rockets because they had little rocket symbols on them as part of their logo. So that's why it's called the Rocket.
Yeah, and that fits in well with the fact that it's a high gain preamp, and which is good in many ways if you can keep the noise floor down. And when we first developed it, the noise floor was extremely low, and then we managed to make a little mistake going from prototype
one PCB to another, and it raised it up, but it wasn't enough that we could detect it in our system, which kind of prompted us to make this this tube lab. Because the rest of the system was so well designed, we actually didn't catch it.
But a couple of our test builders caught it,
Yeah.
and
helped us fix the issue.
Well, Charles fixed the issue, but they helped identify the problem,
Yeah.
and they get a big shout out from us. Test builders normally don't have to identify problems because designs, when they go to market, including to test builders, are normally tested so thoroughly. I mean, it's usually the end of a 6-month period of development.
But occasionally we do make mistakes. We are human after all, and stuff does get out there which has an issue with it.
So this is now version 1.1, and it's now available to the public. And we're actually going to start manufacturing completed kits as well.
We've already started manufacturing completed kits.
More than that, we've actually almost finished the first production run.
Yep.
So we'll have kits available for low voltage regions, so 110 to 120 volts AC, and for high voltage regions, so 220 to 240 volts AC. And they're professionally built. Who else but us would know exactly how to build them
Yep.
to perfection? And they're in the store now. So if you're interested, drop into. I'm actually going to put a link below to yesterday's video on the Melatonin Amps channel, in which we chat a little bit more about the noise issue and
the Rocket and what's coming up next, and
So this is pretty exciting, and the new business and the new website are just the activity level just keeps on going up and up and up. Our hope is eventually that will become the future, because as always, we're going to be using tubes that are available new old stock, that are vintage tubes that are mostly not in high demand, at least
still available.
Yeah, at least they're not in high demand until we start featuring them. And then all of a sudden, everybody jumps onto the bandwagon. But before we feature a tube, we accumulate inventory. So
and try to build some cool stuff around it.
Yeah, so that means moving forward, there will always be tube gear out there, at least from us, in which you can actually get a vintage tube for a reasonable amount of money. And for example, the Rocket uses only 2 tubes. It uses the 6N1P as the voltage gain stage. So 1/2, it's a twin triode, right? Just like a 6SN7 or a 12AU7. So 1/2 amplifies the left channel and 1/2 amplifies the right channel. The cathode follower stage is the amazing 6N6P. This is the greatest tube nobody ever heard about.
Yeah, a few people use it, but a lot of places just ignore it. It's fantastic.
Yeah, and it does basically everything well.
Yep.
So the same thing happens with this. It's another twin triode. So 2 very good tubes to lamp this preamp, I think, are in the store for $100.
Yeah, they're not expensive at all.
Tested, matched, new old stock, ready to roll.
And the rolling options for the V1 tube, this can take a lot more than just a 6N1P.
How many tubes are we up to that can roll in there?
I
Did
don't
we
remember
count
the
20?
exact
Did we
number.
count 21?
There's a lot. There's a lot of different tubes.
Yeah, there's a lot of tubes. So this is a tube roller's either nightmare or best wet dream ever. So, but yeah, I mean, if you're on a budget, just put the Voskhod in, and
It's going to sound great.
It's going to sound
We
great.
built it around it. It sounds amazing.
Yeah. So, anyways, I think that's all we have for today. But if you stay to the very end, here's some discount codes to help you out. Unfortunately, the codes do not work in the new store for the simple reason the margins on these kits is so tight. There's just no way we can discount them. And I wish we could. But
maybe sometime in the future if we get the quantities up or something like that. But yeah, it's just too tight right now.
yeah, so I mean, maybe if we train Jordy to assemble the kits,
You
we
might have
could
trouble.
cut our labor costs down. But he doesn't have any opposed thumbs.
Yeah, and we have to clean the fur off of each of them too.
Yeah, that would be it. I mean, that alone would just negate all the free labor he would give us,
Probably.
and then all the extra food and treats he'd demand. So I don't know. I'm not sure that would work. Anyways, there's a secret code down here at the end that everybody seems to get. Costs us a lot of money, and always
We're fine with that.
yeah, and we're fine with that. It always warms my heart. It means you're actually watching the channel or you're a returning customer, and we've got a lot of returning customers.
Yep. Thanks,
So-
guys.
So we can reach almost everybody around the world with flat rate $20 shipping. And if your order is $150 or more after discount, the shipping's on us, folks. This is Jim
And Charles.
signing off. Stay safe, everyone.